Hi. Okay, let's start catalyst, new topic. Homogeneous and heterogeneous catalyst. So we have discussed about catalyst when we are doing the rates of reactions as well. Unit 5. Yeah, still. Make it. Okay. Two types of catalysts are there, homogeneous and heterogeneous. How to define catalyst? Sorry? Homogeneous, heterogeneous, yes? We did this in unit 4. Then again, unit 5. What is heterogeneous catalyst? Okay. Reactants and products are in the different physical state. It's a homogeneous catalyst. Catalyst, reactants and the products are in the same physical state. It's as a property of transition metals, we started with transition metals are catalysts. They can act as catalysts. Properties. The first case, heterogeneous catalysis, right? Then heterogeneous catalysis means reactants and the products are in the different critical state. Catalyst means how to define catalyst? Yes. How to define catalyst? Without being used apparently.
Not changing.
Yes. No. Pranav. What is catalyst? Define catalyst. Define catalyst. Define catalyst.
Catalyst is a factor that accelerates the rate of reaction without being used up in the reaction.
Without being used up term being
chemically altered.
Yes. Speed up the chemical reaction by providing an alternative pathway with evacuation and remains chemically unchanged. Chemically unchanged. Chemically unchanged and the physically unchanged. Right? Right. Remains chemically unchanged. Hurry. I think we discussed how to show the action of the catalyst using the Maxwell-Boltzmann curve as well. Okay. Recording in progress. Recording in progress. Okay. Write the topic, main topic, heterogeneous catalysis. Then the subtopic, transition metals as heterogeneous catalyst. Yes. Transition metals as heterogeneous catalyst.
So how to study?
Study. Are you? Unit 5 වලට ටිප් එකක් දෙන්න නැති වෙන්නේ එක හේතුවකුත් ඒක තමයි. කියන්නේ ඔයා වැඩිපුර ඒක පාඩම් කරන්න ලියන්න ඕනේ. ආයෙ පාරක් නෝට් එක හදන්න. ආයෙම හදන්න ලියන්න. කොලෙන්ද? ඉතින් එහෙම තමයි unit 5 කියන්නේ ඒකනේ. this unit 5. දැන් ඉන්නව මම මෙහෙම හරි unit 5 කරලා ඉවර කරනවා. at least එතකොට by January unit 5 ඉවරයි. මේක අපි අන්තිමට කරන්න තියාගත්තම කොහොමද ආතල් එක? right. okay. එන ලියන heterogeneous catalyst is in a different phase from that of the reactants. Heterogeneous catalyst is in different phase from that of the reactants. Right. Example, manganese 4 oxide. Manganese 4 oxide. MnO4. MnO2. Manganese 4 oxide and MnO2. In decomposition of hydrogen peroxide. Oh. Hydrogen peroxide will decompose into water plus oxygen. This reaction will reaction will speed up by addition of manganese 4 oxide. MnO2 will act as a catalyst on decomposition of hydrogen peroxide. This produce water plus oxygen. This reaction produce water plus oxygen. Many transition metals. New point. Many transition metals and their compounds are used as many transition metals and their compounds are used as solid catalyst. Solid catalyst. Right. And their action can be explained. And their action can be explained. And their action can be explained in terms of what happens on the surface of the catalyst. What happens on the surface of the catalyst. This is known as surface adsorption theory. Adsorption, AD. Surface adsorption theory. So the heterogeneous catalyst, action of heterogeneous catalyst can be explained using the surface adsorption theory. Okay. There's a nice diagram for that. Surface adsorption, AD. එතකොට අන්න මේක question එකේ කියන්නේ මෙච්චරයි. What will happen, like the action of the catalyst can be explained by the surface absorption theory. So the reaction take place on the surface of the catalyst. Solid එකන්නේ. We are using a solid. Liquid මුකුත් නැහැ. Transition metal solid we used as catalyst කියලා. එතකොට good. Okay, 1 second. There's a nice diagram. I'll share the diagram first of all with you.
මොකක්ද UUT කියලා තියෙන්නේ? අර යටින්ම තියෙන උඩුන් ට්‍රේන් කියලා එනකන් නැහැ.
මොකක්?
අර 113 කොපනිසියම් වලට පස්සේ තියෙන
එලිමන්ට් එකක් ගන්න.
ඒ මොකක්ද?
ඒක දන්නේ බලමු.
113 මෙතන කොපනිසියම් 113 එකක් නෑ. හරියට දෙවන ඉවරයි.
The next topic, surface adsorption theory. Yeah, the topic surface adsorption theory. So an example, iron in Haber process. Oh, example, iron in Haber process. Iron in Haber process. Haber process means production of ammonia. Now, ඔයාලගේ book එකේ steps 3යි දීලා තියෙන්නේ. Haber process. ඔයාලගේ book එකේ steps 3 මම කැමති මෙන්න මේ steps 5 විදිහට තියන්න. This is the action. හරිද අපි මේක ලියාගමු. So the reaction for the Haber process, wait my දෙන්න. You can copy this, wait. Before writing this, you can write the Haber process equation. Got girlfriend? No problem. That's your freedom, no problem. Make this reaction. This is the reaction. This is the reaction. F is the catalyst. Let's write these 5 steps starting on a diffusion. Diffusion means the reactants will diffuse to the surface of the iron. Adsorption, these gases will adsorb to the surface of the iron, which is the catalyst. Now what will happen? There are bonds between nitrogen weakens and they form new bonds with nitrogen and the surface of the iron. Hydrogen weakens and form new bonds with hydrogen and the surface of the iron. And then they can easily react together, right? So strong enough to weaken the covalent bond within the nitrogen and hydrogen, and weak enough to break and allow the products to leave. Because then they react, and then desorb. Desorb means removal, and then diffusion. Those are the steps. Now you can write. Finish writing? Right, done. So the steps are the diffusion native not diffusion adsorption, reaction, desorption. That is what is given in the textbook. Adsorption, reaction, desorption. So this is nicely explained in this diagram. Hey, please. You can copy this diagram as well. So you can see, don't write, don't go. Nitrogen and hydrogen will diffuse to the surface of the catalyst. They will form new bonds with the surface of the catalyst. That is the adsorption. And then they react and then desorbs. React, desorb. Adsorption means that is adsorption. Adsorption. What drug inject adsorption. Adsorption. Going inside. You can remember adsorption. Difference. Adsorption. At least take a karane bonds weakening with it. Oh, yes. Clear. Yes. Can call it a for now. Why don't you switch on the camera? No. Okay, copy. Right. So that's it. There's another example. Maybe another one. Nickel in the hydrogenation of alkenes. See, hydrogen atoms diffuse, adsorb and react and desorb. Just diffusion, adsorption, then react. Make a calculate not complete. Incomplete. 2, 3, 4 3th make hide alkene part again. It's not there. This shows it's make a pen partly. So another example, vanadium oxide V2O5 in contact process. Example number 2, vanadium oxide in the contact process. Now here they are explaining in terms of oxidation number. Here what will happen? The sulfur dioxide adsorb onto the surface of vanadium oxide and the redox reaction occurs. That process still continues. Adsorption, reaction, desorption. So here adsorption, V2O5 will accept sulfur dioxide and form V2O4 and SO3, right? So there's a redox reaction taking place. Vanadium, oxidation number of vanadium decreases from +5 to +4, right? And then the formed vanadium 4 oxide then react with oxygen to form vanadium 5 oxide back. So remains chemically unchanged. Write down example number 2, vanadium 5 oxide V2O5 in contact process. contact process is the no, contact process is the mechanism that used to produce sulfuric acid. Sulfuric acid. So the reaction that vanadium 5 oxide involved is yes, reaction that vanadium 5 oxide involved is this. SO3, this one. Okay, you can copy this. Yes. Okay, now you can copy the diagram. No, not the diagram, the details. Okay, in this reaction again, what will happen? Vanadium 5 oxide react with sulfur dioxide. Forms V2O4, right? Vanadium 4 oxide and sulfur trioxide. So oxidation number of vanadium decreases from +5 to +4. And then the form vanadium 4 oxide react with the other reactor, that is oxygen. And it forms the vanadium 5 oxide band. See? Okay. Another example is catalytic converter. What are catalytic converters? Very good. So the catalytic converter found in the exhaust pipe of the vehicle, they convert they convert oxides of nitrogen into nitrogen and carbon monoxide into carbon dioxide. Yeah. Oh. So the catalytic converter will catalyze this reaction. Okay. Catalytic converter will speed up the process of converting carbon monoxide to carbon dioxide and oxides of nitrogen into nitrogen. Catalytic converter. Number 3. Catalytic converter. There are, sorry, catalytic converter machine name a part of the vehicle. Oh, so pipe. There are 2 major pollutants in vehicles exhaust. There are 2 major pollutants in vehicle exhaust. Pollutant. Two pollutants in vehicle exhaust. Number 1 is carbon monoxide. Another one, carbon monoxide and oxides of nitrogen. Oxides of nitrogen. That's the nitrogen monoxide. And then you can carbon monoxide and nitrogen monoxide. Okay. Carbon monoxide will reversibly react hemoglobin, reduce the oxygen carrying capacity of the blood. Nitrogen monoxide is respiratory irritant. Maybe you can copy this. Copy this one. Now, as a solution for the emission of these gases, right? Catalytic converter is fitted in the exhaust pipe of the vehicles
Is fitted what?
In the exhaust pipe. Catalytic converter is fitted in the exhaust pipe of the vehicles. And the catalytic converters are made of transition metals such as platinum, rhodium, or palladium. Platinum, rhodium, or palladium. It's like a honeycomb mesh, and it looks like a honeycomb mesh. And the overall reaction happens is this. And this reaction is catalyzed by this transition metal. And again, the same principle, adsorption, reaction, desorption taking place. Copy this. Sorry. Okay, quickly copy. So we are done with heterogeneous catalyst. Okay, shall we? Sorry. Answer this one. Checkpoint 1 and 2, please. Lama, checkpoint 1 and 2, please. Please do this. Acid rain means nitric acid and also sulfuric acid both.
Nitric acid and nitrogen.
It's enough. But here we have to consider about nitric acid because NO2 and CO. Price.
අව අපේ අම්ම අද මේ මොකද්ද වෙන පොතක් ගන්න කියලා ඒක 520 එකකට 12යි.
585. මේකගේ පුත. 200.
ඔව්.
Okay.
at least I feel.
Shall we discuss? How does the description of catalytic 2 of vanadium 5 oxide show the catalyst but does not take part in the reaction? Take a වැරදි not true. Take a වැරදි no. Catalyst will take part in the reaction. Yeah, it remains.
Then we do for reaction half O2 and use V2O5 back.
Yes.
V2O5 take part in the reaction.
Yes. So what will happen? Vanadium 5 oxide react with form V2O4 and then it will react with oxygen. Then only it forms V2O5 back. So remains chemically and the best term. How nitrogen monoxide can form acid rain? NO plus O2 gives you NO2. NO2 plus water HNO3. OH minus H2. Nitrogen dioxide dissolves in water forms. Next topic, homogeneous catalyst. And then subtopic, transition metals as homogeneous catalyst.
Check in it.
Transition metals as homogeneous catalyst. Then write down homogeneous catalyst. You can use the same homo there. Is in the same phase. Homogeneous catalyst is in the same physical state, same phase as the reactants. As the reactants. Right. And then example number 1. Example number 1. Reaction of S2O8 2 minus ion. H2O8 2 minus. H2O8 2 minus. Reaction. Now here what will happen? H2O8 2 minus will react with I minus to form SO4 2 minus and I2. Those are the two negative particles. Negative. Positive repel. Negative particles and negative particles repel each other, right? Therefore, they will be having high activation energy. Difficult to react. Therefore, you had used third party, that is Fe2 plus. So H2OH2 minus will react with Fe2 plus to form SO4, one of the product, and Fe3 plus. Then that Fe3 plus then react with the other reactor to form the other product. Clear? This explains how the homogeneous catalyst will work. So the all are in the aqueous state now, right? But Fe3 plus will take part in the reaction, but remains chemically unchanged at the end. Okay, and now copy this one. Put the box at the end. Can't this reaction happen in the other way around? Can't we start with Fe3 plus?
Fe3 plus.
Yes. So Fe3 plus with I minus to form Fe2 plus and I2, the produced I Fe2. Fe3 plus react with I minus to form Fe2 plus and I2, and the formed Fe2 plus can react with H2O2 minus. So the reverse is also possible. So the catalyst can be either Fe3 plus or Fe2 plus. Okay. Fe2 plus or Fe3 plus. Okay. Copy this one as well.
Yeah, no, sorry, I need that.
කියලත් මට අතේ තියන්න ඉතින් කොපි කරනවා කියලා දන්නේ
මම බලන්න ප්ලෑන් කරාම ඉන්නේ හැබැයි දෙකත් එක්ක. පැලිකින් මුතුලම කරගෙන. ඕනෑම දෙයක්.
Finish writing?
වැඩ කරන්නේ නැහැ. මෙයා මාර්ග ටෙස්ට් මුලින්ම දියන්නේ.
මම කියන්නේ බෑ මේකේ රෙකෝඩින් එක වදිනවා.
හරිද? ඉදිරියට
Right. Okay. Example number 2. Oxidation of ethane diode. Still writing? Oxidation of ethane diode. Now in this case, what will happen is, okay, first write this reaction. Okay, write this one. This is the example. Oxidation of ethane diode. Just write the reaction. Don't. Sorry. Now, this reaction is slow to start. This reaction is slow to start. Right? This reaction is slow to start, but therefore heating is required. This reaction is slow to start. Therefore, heating is required. However, as the reaction proceeds, reaction will speed up. Reaction will speed up. This is because the produced Mn2 plus. Mn2 plus will catalyze the produced Mn2 plus will catalyze the reaction. Will catalyze the reaction and hence speed up. Yeah, this is known as autocatalysis. Autocatalysis. Hence legs. Legs. Okay, that's it. Done. Not even. Okay. Checkpoint 1 and 2. Oh. So another lesson in unit 5 is done. Yes. Unit 4 තුන්වෙනි කියවරෙන් යන්නේ. හෙට හතරවෙනි පටන් ගන්න. Okay, yes. Copy this one. Copy this one. Sorry, not to copy. Please answer this. State do not act as a catalyst. What was the property in the H2O8 2 minus and I minus reactant? Iron 3 plus goes to iron 2 plus. No, iron 3 plus goes to iron 2 plus and then goes back to 3 plus. For that, it has variable oxidation state. But Mg2 plus has no variable oxidation state, only plus 2. Again, it can reduce, it cannot further oxidize. And Mg2 plus can reduce but cannot oxidize. It is why autocatalyst reaction will not take in place under alkaline conditions. Lazy. So what will happen? Alkaline condition mean OH minus is there. The OH minus will react with Mn2 plus. Reactions of manganese with sodium hydroxide brown precipitate. So that if that precipitate happens, catalyst no more. So the reaction will stop, slow down. So what will happen? Mn2 plus, produced Mn2 plus will react with OH minus, forming MnOH2. Done. So this reaction or so this lesson also over. So we'll do some questions. Are there? Okay. And we'll start with this. First, answer these 4 MCQs in 4 minutes. Okay. Start. Who will be the lucky one? Okay. 558, 62. 7 is there. Okay, 1 minute more. Shall we discuss? A precipitate of copper 2 hydroxide is solid in aqueous ammonia. What is the formula of the complex ion form? Hands up, who are with C? D. Evany, what is the answer? This answer. Answer is D. D. Ammonia with copper forms 4. Yes. With copper 4. Next one. What is the configuration of the ion cation that can form the complex ion FeCN4 minus? So here Fe should be 2 plus. Why I am telling it 2 plus? Overall charge is minus 4. CN6 means minus 6. Minus 6 minus 4, and it should be plus 2. So what is the configuration of Fe2 plus? Fe is argon 4H2 and 3D6. Next one, titanium has the following electronic component. Which of the following compound unlikely to exist? The maximum oxidation number is you can remove both D electrons and S electrons. 4S and 3D are having similar energy, so you can remove. Yes. Whether plus 4, here plus 2 oxidation state is there. Here plus 4 oxidation is possible. Here this case plus 3 oxidation state. That one also possible. And here, plus 6 not possible. So the answer is okay. Colors: orange, yellow, green, blue. Orange, yellow, green, blue. Bindu. Okay. Next two, please. Next two, please. Then I make it the fourth thing. 3 and 4, please. Right then. Anti-cancer drug cisplatin formula is this. What is the oxidation number of platinum in these substances? Platinum oxidation number. Ammonia has no charge. Chlorine has -1 charge. Therefore, platinum cisplatin is +2.
Yeah.
Then aqua complex also +2. Because one Cl is there. So +2 and -1 is +1. So the answer is B. A compound of chromium with the general formula Cl3. Make a common exam question. When an excess of silver nitrate added, only 1/3 of the total chloride present is precipitate. What is the formula? Now, the formula they are saying is CrCl3 it's CrCl3 dot 6H2O. There are several possibilities that this can arrange. It can be CrH2O6 3 plus and 3Cl minus outside. Another CrH2O5 Cl 2 plus and Cl minus 2Cl minus, or else Cr H2O4 Cl2 plus and Cl minus. These are the possibilities. The question says only 1/3 will precipitate as AgCl when you add silver nitrate. So if you add silver nitrate to this, all the chloride will precipitate. They will remain as ions. Then 2/3. 1/3. So the answer is this. Okay, done. Okay. Question number 8, please. Okay, seventh one is MCQ. Okay, seventh one. What is the hexa copper ion? Why the copper ion is blue? Ligand causes d orbitals to split into two different energy levels. Electron in the lower level will absorb energy from the visible light and to a higher level. Color complementary to the absorbed color can be seen. If the PP transition is wrong, therefore we can simply remove the A and C answers, right? That's got water can split the d orbitals and dd electron transition absorb all but blue light. The water can split d and the dd electron transit and emit. No emission will take place. Color complement to the absorbed color can be seen. Okay. Right now, question number 8 is Right. Complete electronic configurations. SC3 plus 2P6. Latushan, what is the answer?
Yes.
Hey, Tamai.
3S
3S2, 3P6, and 4S1 to 3D1. 3D remains. 4S goes first. 4S is the outer motion. Hari 4S calling ena පිරෙනකොට යනකොට 4S calling. Explain why titanium is a transition metal but scandium is not. It forms one or more stable ion with incomplete field desorption. So scandium has only one ion. It has no d electron. Titanium forms titanium 3 plus, has incomplete field desorption. Oxidation number of scandium here is +3 and the titanium is here.
1, 2, 3, 4, 5.
Question number 8 is done. Question number 9. And 8 continues. And 9. 9 only give. Yes. No. Right. What is the meaning of the term ligand? Anion molecule that is able to donate a long pair of electron to form a dative covalent bond with the central metal ion. Tetra aqua hydroxo iron 2. Fe H2O4 OH2. The next one. Give the name of the complex, please. Yes, Mimish, name? Oh, cobalt name. Cobalt. Tetrachloro. Cobalt 2. Then make a negative ion in the negative ion in the put that Venus. Tetrachloro. No. Recording is progress. Yes. Putayin balam may hitan may inna balam mo kinetics. Tetracolo anari. Make a cobalt name. Cobalt 8. Cobalt 8. 8 in negative ion. Because it's a negative ion, that's my make it one. Next one. Okay. Explain with the reference this diagram why solution containing complex is colored. Ligand cause d orbitals is split into two different energy levels. Electron in the lower level will absorb energy from the visible light and move to a higher level. Color complement the absorbed color can be seen. If you want, you can write this answer, sample answer. Where are you going? Okay. Hari, that's it, and that's it for today. I'll see you tomorrow. God bless you, Lamai. Night then.
Good night.